We need to find the residue of 1 divided by z square plus a square whole square at z equal to iota a. So for that, first we need to find the singularities by taking the denominator equal to 0 and getting the value of z. So for this function, writing the singularities of fz are at taking the denominator equal to 0. So from here I get z square plus a square equal to 0 and z is equal to plus minus a iota, right? And we need to find the residue at z equal to a iota, that is one value among these two. Because I'm having the power 2 over here, so I must write the singularities of fz are at z equal to plus minus a iota, each of order 2. If I'm having the power 2, I must write the order 2. If there is no power, then that will be a simple pole, right? If the power is 3, then the order is 3. Here the order is 2. So now finding the residue at z equal to a iota, and now finding the residue at z equal to a iota. And the formula to get the residue is, if I need to find the residue at z equal to a, the formula for that is 1 divided by m minus 1 factorial, limit z tending to the point where you have to find the residue, d by dz, taking the derivative but m minus 1th derivative of z minus a the power m into f of z. If we are having the power m, I must write m minus 1 factorial over here, and I must take the m minus 1th derivative of this, right? Here we are having the power 2, so for that I'm having here m equal to 2, right? So from this formula I'm calculating the residue for m equal to 2, the power. So this is 1 divided by 2 minus 1, that is 1 factorial, limit z tending to a iota. Here I am having the point a, here I am having the point a iota, right? Taking the derivative m minus 1th time, that is 2 minus 1, that is 1. So only we need to write the first derivative of z minus the point, that is a iota, the power 2 into f of z, that is this 1 divided by z square plus a square whole square. Very fine. So this is equal to limit z tending to a iota d by dz of z minus a iota whole square into, I can write z square plus a square as z minus a iota into z plus a iota, taking the square, right? So these two cancelled out with the square, and this is limit z tending to a iota d by dz of 1 divided by z plus a iota whole square, right? So now derivating this with respect to z. So this is minus 2 divided by z plus a iota the power 3 into the derivative of z, that is 1. And now taking the limit z tending to a iota, just replace z with a iota now. So this is minus 2 divided by a iota plus a iota the power 3, that is 2a iota the power 3. So this further becomes minus 1 divided by, this is 4a cube iota cube. And what is iota cube? Because iota cube is what? It is iota square into iota, right? And iota square is negative 1 into iota. So that gives minus iota. So this is minus iota, and this minus cancelled out with this. You can also rationalize this by multiplying and dividing by iota. Iota square is again negative 1. So this is minus iota divided by 4a cube. Minus iota divided by 4a cube. It's your choice how to write. That is also correct and this is also correct. Okay, thank you. Stay blessed.